That is a good find about
Yeah,
AWS.
y'all caught up? Lessons?
That AWS article which you found,
Yeah,
that is a good one.
yeah.
It's interesting. Similar to the, what is that outage which was there last week, couple of weeks back?
GitHub.
Yes. Sounds very similar.
Yep. The good old RM command, huh?
I'm sure they're getting there to remove the permission on that command.
Yeah, no doubt.
Or you have to type a 14-digit password
Yeah.
by 4 people.
Isn't that fun? It's always people that make mistakes. And you blame machines for mistakes, huh?
Right, exactly.
Yeah, people make mistakes, and it's a good thing. It's a good thing that we do, because that's what we are. We are meant to make mistakes. We should be like that. People should make mistakes. Continue to make new ones. That's it. That's the only thing that you should remember, all of us.
Yeah, you just keep making the same ones.
The film should have cost Amazon what? How much? $500 million?
Yeah, people have been claiming quite a bit of loss numbers all over the map, but we'll see what that actual number actually is, and it'll come out. News will come out soon, eventually.
This is the biggest AWS outage that I've heard of.
I guess so. Lots of people impacted, and yeah. I think outages are in a way fun, at least fun for me, because I get to talk about these things in our live examples in the bootcamp. That occasionally, almost every other bootcamp that I run, there is some kind of an outage that I have noticed that people run into, and sometimes one of those times I remember it impacted us, and so the site would not open, and all that thing happened. Quite a bad one. And then, if I remember, I think I told you about this thing called Namecheap, DNS outage.
Yep.
That's what impacted me and Cloud Genius quite a bit. I think this is about 2 years or so ago. And so those days I used to use these guys as my DNS server, but not anymore. Not anymore.
Is that what spurred you to move over to Cloudflare?
Yeah, we went to Cloudflare. Before Cloudflare, I went to this thing called Route 53. And then I decided that I should try Cloudflare also, because it is also supposed to be good. And since it is decent, what I liked about Cloudflare is the fact that it has the CDN capability. That's the thing that I like about it. And so having the CDN at hand makes it interesting. So if I can turn on CDN capabilities as and when I need to, I could. Although I haven't actually made much use of the CDN capabilities as such, but the fact that it gives you content delivery network plus DNS plus a whole bunch of other things, all of it for a very affordable price of $0. It's a no-brainer, right? And that's what I like about it. And one of the persons who used to work for that company, Cloudflare, actually I know him personally. That's why I decided to switch over.
Right on.
And it is working out okay. I think, for me, at least up until now, I have had no issues as such. So I think we should get started, and make sure that we are watching this SIA database skills. Have you watched this video? You should watch it. I posted a link for you guys. If you haven't seen that video, you should watch. That's funny. And then what else? Let me close out a couple of windows that we don't need. And then we get to the topic of discussion pretty quickly. These things can go. This thing can be in here. The news article that Eric pointed out. The summary is turning out to be, I haven't actually read this article, but Eric tells me that the summary is that it is human error, which is, yeah, that's how it is.
Somebody got a little aggressive with the RM command.
So let's see, where is the reference to RM command here? Is there any reference?
It isn't, but they're talking about removing a couple of, they're using a command to remove some S3 instances. So I think it was more up towards the top.
Aha. This will prevent an incorrect input from triggering a similar event in the future. You see that line?
Yeah.
Yeah.
So only thing, Nilesh, I mean, the thing is, should we take this at face value, or because this can be an easy way to shift the blame as being a human error, right?
No, it's not. It's not taking. They're not passing the buck. They're taking the blame. So I would agree. There is nothing to distrust them. They're not lying. They are saying it is human error. Human error is not an excuse. It is an error. And they are taking the burden, they're taking the blame. So I don't take this lightly. They're not passing buck. They're saying, we are sorry, we are stupid. That's the comment. Basically, if you think about, this will prevent an incorrect type of input. So it's human error, basically. We have modified the tool. So it's an operational event. A removal of capacity is a key operational practice. And so they go into further detail, probably somewhere here, saying that.
Yeah, up top it says established playbook executed a command which was intended to remove a small number of servers.
Right. Let's focus on that line. So can you help me locate that line?
Third from the top.
Third from the top. So here, established playbook. So it is at this time, authorized person using an established playbook. So it's a standard procedure, right? Executes a command which removes a number of machines used by the billing process. So one of the inputs to the command was incorrectly entered and a larger set of servers was removed from that intended. And that is a nightmare. It is a nightmare that happened, and so it led to loss. And that's how it is. So they're not shifting the burden or taking the blame somebody else. They're blaming themselves, which is, I think, the right thing to do. You just acknowledge that you made a mistake. And at the end of the day, it is some person, right? They're not pointing a finger at a user saying, you are stupid. They're saying our employees made a mistake. And so it's the companies taking the blame. So there is, I have another case going on right now with I'll show you that case, so that will help you. Similar thing. You will notice that this case is open. So in that case, they are taking precautions so rigorously. And the bottom line, the case is, let me get to the issue or the case. They're also deleting things for me, by the way. And I'll tell you what is being deleted. So since my account is old, you will notice that when I go to EC2, and if I am in Northern California, which I'm currently right now, you will not see it because they have successfully deleted it. But I will change my region to something like Northern Virginia, and then go to EC2 and look at security groups. You will find that I have unnecessary security groups here that I cannot even delete them. And there is this classic default group I cannot delete no matter what I do with it. This is a mistake. So there's no checkbox, I cannot delete, and nothing happens. The reason is this used to be before VPC came out. The VPC feature came out. Amazon used to be a whole lot simpler several years ago. There used to be just one IP address range, and in that address range you can get a machine connected, and if you start a new machine, it gets an IP address, another machine, another IP address, and all of these IP addresses were like public IPs. they were pretty much similar to DigitalOcean. You get a new droplet, you get a new IP address. That's what it was. And this was called the classic mode. But later on, it was called the classic mode. That was the only mode to begin with that they had. But today, or rather, actually, maybe 5 years ago, they started this VPC thing. In the VPC scenario, you have, nothing is on the public IP unless you tell that I would like to have machines connected to the public network. So you create a new box, you get a new IP address, new box, new IP address. You can get that if you ask for it. By default, everything is in the private IP area. And the whole cloud is inside a virtual private area, VPC, virtual private cloud. And that is the new default. And before that, it used to be this mode, and they just call it classic mode. They used to have security groups for that, and that security group is the default security group that you see that I cannot delete. Although I asked them to delete this classic thing, I don't need it anymore. I just give me everything in VPC. That's what I would like to have. Like every new customer has only VPC. They don't even have the other option, which is somewhat less secure, by the way. And so I wanted to get rid of that option. And so they deleted the option for me, but then left the security group entry by mistake. Human error again. So here is a example of this classic default security group. I cannot delete no matter what I do. So I open up a case and I tell them. And so the case discussion is going for I think it's like a 2-year-long case going on. I tell them, please delete these for me. And so these security groups I want deleted. And they say, you know what, cannot, really delete somewhere along the way. It says, I understand your concerns. The rules you create, you have to delete yourself. And I said, okay, you know what, here is a video. See, I cannot really delete. Note the error. I could not delete this. I tried, I could not delete. It's not possible. And so they said, yeah, fine. But then, we open an internal service ticket. And then they come on and say that, thank you for your patience, still looking. And then they say that, you know what, let's keep going. Let's keep going. Keep going. I think it's like ancient. So we tell them that, our people that participate in our program might get confused because these security groups are not deleted. And I don't want them to be confusing anybody who's looking at our screens. And that's the business logic. They wanted me to give them a business justification to delete stuff. And they come back saying, okay, we get that. We'll try harder for you to delete them. And then, we are going to do it manually. So please tell us in one region you would like us to delete. So I tell them, okay, go delete this in US West 1 region and please proceed. And they come back telling me that they have deleted it. They want me to confirm that. So I confirm it. And they say, okay, so you really had no problems? And I say, yeah, correct. And then I said, okay, delete the rest now. So they gave me a tentative schedule for next open change window on Monday, March 6th. They'll get rid of it eventually. So, for the last I think about close to 2 years, this issue has been going on. But the challenge is they make mistakes, like everybody else. Nothing wrong with it. Bottom line, it has been acknowledged. So there are people will eventually, get compensated. Companies will get compensated for the loss or something like that. They'll give them some money in form of compensation for a loss that they may have. But again, it depends on SLA agreements that they may have. They may have special ones. For most small companies and medium-sized companies, do not give you a special SLA. So they are basically screwed. And they'll just eat the cost. And so moving on, I think my cough is improving, so I can speak properly, I hope. Probably.
Nilesh, did you tell them about the Cloudflare security breach?
Yeah, almost all of us got that email. And that security breach we discussed the other day about Cloudflare, and I saw your email and all that. And so you have forwarded that email. That email basically says that I said thanks to it, apparently. So we discussed that briefly. Where is that message? Somewhere I saw your message and I then said thanks, and then what happened to it? Did
No,
I
that's
not
fine.
reply to you?
No, I saw that. I saw your reply. I just wanted to bring it to the class.
I see.
Yeah.
I see. Though, where is that email though? I don't see your email. Huh? Interesting. Is it in trash or spam or what? No, not in trash. There. So this message came, which probably all of us got because all of us have this Cloudflare incident that happened. The bottom line to Cloudflare is that the issue with Cloudflare is that you should change your password. That's the risk that you have, apparently. And so it looks like Shiv has been using this Prosper service, which uses Cloudflare. So Prosper is telling Shiv to reset the password, which is, I think, it's a good thing that you do. The best protection available today in terms of protecting your passwords is to use a second factor, which you probably have taken note of and are already using that today, given that I know most of you have seen me use this token generation method of some sorts to generate a new token. So two-factor authentication. I think sorry, not this. Two-factor authentication. I think you have seen that already. And this you should read. If you haven't implemented that in your day-to-day life, you should absolutely consider that immediately. And that is this article to read. And the easiest way to implement this is to actually use your phone. Phone SMS-based two-factor. And so okay, now they're claiming SMS-based two-factor is insecure. Fair enough. So yeah, move on to using something like 1Password then. 1Password or see, even simpler, Google Authenticator. This app you have, I think, should be good enough for you to protect yourself. This application is available on open source. You should be able to get that in this location. In Wikipedia, there is a link, and it's available for Android, iOS, BlackBerry, and other platforms. You should be able to use those application implementations to generate a second factor token. Like, for example, here is the iOS app that is available from where is the link to that? Link to the app? iTunes. And in the iTunes store, you say Google Authenticator. Should bring it up in the store. Say search. And here it comes. The app should come and you should make use of it. If you haven't using it, use this app. That is what I am suggesting that you please do. And it generates tokens like this that you incorporate into your second factor flow. And so for Cloudflare, you do the same thing, basically. Cloudflare forces you, I think, to use Authy, not this. So there's a different solution for Cloudflare, which is what you should use. It's available, like it works like, where is that? Upgrade to Authy, download Authy, and that's the app. So you can see me using it. And this is the app will generate a token for Cloudflare. Since Cloudflare is not open right now, this token is showing a phishing alert, which is totally appropriate. If I go to Cloudflare, try to log in, and when I log in, it'll ask me for a second factor token. And it did not ask me because I've been logging into this site quite a bit. So it did not ask me for that second token, but it can be generated just like that. And you can copy and use it and go forward in using that. So this is another tool called Authy that you should absolutely use for every single thing, specifically your banking operations. If your bank does not allow second factor, you should ask your bank to basically start second factor authentications. And if they don't agree with you, I suggest changing your bank. So begin with your bank, your credit card, your brokerage, your financial institutions of other types, and then your email, and then your social media, and any other accounts you have online. make sure that they are forcing two-factor on you. And that will help you in generally speaking. And so let's move with that, we move forward. Okay, so we were talking last time about a couple of these reference architectures, and we discussed fault tolerance and high availability. There are certain things here that I would like to make sure that we address. There are a lot more charts in here that need to be covered, but we don't have enough time. So I would like to, basically expedite to the extent I can. At the same time, giving you real world examples that relate to these pictures so that you can basically get an understanding about how these illustrations of architecture apply to a given situation of a scenario where, why is not everybody here? Like there are 5 people right now. Huh? Where is everybody? What day is it? Thursday. And it's 4 o'clock. I can understand that part. So they'll come. Yeah. So I was curious as to why only so many people.
Just your favorite students.
Sorry?
Just your favorite students are here.
I know, sir. Yes, you're right, sir. Others are tired of me, I guess. That's what it boils down to. So, but I noticed that people show up at other times, like random hours during the middle of the night. I have seen people come and visit the site, which is crazy. But that's good, actually. It's a good kind of crazy. So moving on, what I want to do is pick up a little bit of pace. And if you think that I am going a little bit too fast, you can always ask me to slow down, and I will. If you think that I am not going over a particular aspect and that you're interested, you should ask me to slow down. I will like to speed up because I want to cover this whole thing today. And then I want to do a real life example of implementation of something like this through automation. We have done a variety of exercises. We have done a variety of exercises with DigitalOcean. I want to do a complex exercise with one of the more complex clouds, which is this Amazon cloud. And we have that already. I ran that exercise just this morning, and I'll just point you to the exercise where that exercise is. And that one is, it's a multi-tier architecture using Terraform exercise in the architecture sequence. And I'll point it out to you so that I intend to cover that also, either today or the next time, Saturday morning. Depending on how much time it takes for me to explain that, because actually the actual action of running that exercise is trivial. It's all automated. It is right there, this one. And tier architecture using Docker and Terraform. You can click that exercise and read it and run it in like 10 minutes. But that's not the point. You literally, there's not much steps to do, just run the command and it runs. It magically creates the whole thing for you, but I don't want it to remain magic. And so that will take me time to explain to you line by line as to what that level of automation is that will bring an entire virtual private cloud with running live applications inside Amazon cloud. And that exercise is available in this location, GitHub. As you can see it, it's there. And this part is a little bit what I want to go explain to you line by line. So I'll run this segment of code line by line to help you understand. And you can see it running, you can relate to it as to what you will see when you visit the Amazon console and the actual application that gets loaded. And we'll do load balancing, or, elastic load balancer, Docker, scaling, all of those aspects. You will see that in that example. It is a comprehensive built ready example that runs very quickly, but running is not the point. The point is to understand what is going on. And that's what I intend to do with that exercise. But for right now, let us proceed. So we covered this, web hosting. We have discussed this already, content and media sharing. This batch processing, I think may or may not have covered. We discussed fault tolerance already. And what I want to do is discuss this one, large scale data processing and huge data sets. And so for that, I would like to bring up the PDF file and download it locally. And this file, what I would like to do is you just put it on my desktop, open it up from there. In the chat window, I think Oracle Cloud is the most complicated. Okay, For some reason, I cannot get an EC2 equivalent to be created. So I think, Shiv, I want to see your Oracle Cloud. Share your screen with me later on, and we'll figure it out, what's going on. And it should not be a problem at all, but we'll see. So after the session, we'll talk. Back here, I want to open that. I don't doubt that it is, it could be complicated, because the thing is to be complex, but not complicated. I think what may have happened is it may have been complicated. It may be complex, but it should be still usable. And that's the difference between complex and complicated. You don't want to be complicated. You want to be complex enough so that you can actually deal with real life situations, but doesn't mean that you become complicated. And so, yeah, some companies behave like that.
I mean, if you can log in and do a simple task, I mean, then you kind of lose hope at the first shot, right? That's what
I know.
Feeling is very bad. So
yeah, don't feel bad, and in fact, don't even you should actually feel happy about the fact that your company is decided to use that particular cloud, because otherwise they will not be using any cloud, and then you are stuck. So
yeah, right now Azure is winning over Oracle Cloud so far.
Okay. Happy that your company is progressive and just make the best out of what you have.
True. Okay.
Sweet. So let's proceed. So in our picture, this idea about large-scale data processing, huge data sets. This idea kind of sort of reminds me of your company, by the way, Shiv. Shiv's company is a utility company. It's on the East Coast. It is like Puget Sound Energy of our area. Or his company is called Exelon. Exelon company is a utility company. It's Constellation Energy. Exelon. And so that company, as you can see, is based in Chicago. And what they primarily do, if you look at the company, is what do they do? Let's go see about.
Yeah, we also generate power, Nilesh. We are the biggest nuclear power generators.
Right. So they're America's leading energy provider. Right. So in case of energy business, there are 3 actions that need to happen. The 3 actions are: you have to generate electricity, you have to transmit electricity, and then you have to distribute electricity. Did I type it right? Yeah. Distribute. So generation.
We have a big trading floor also.
Yes. So trading of energy will come into play, but it's like, at the level of when you generate, you can trade it at this point, or you can trade it at this point. And so trading can happen in these 2 locations, or in these 2 places. You can trade whatever you generate. You can either send it to your transmission pipes and eventually distribute. If you have some surplus that you cannot actually consume, then you sell it. And that selling is trading to other companies. Similarly, at some point, when you tend to distribute energy and you're falling short of your energy source, then you want to buy energy. And this buying is also trading. You buy from other people. And this buy and sell operation essentially constitutes trading of energy. You give and take with other people on a global scale, maybe on a national scale. So if this is the US map, for example, and you have Exelon Energy producing say 10 gigawatts of energy at a given time, and this neighboring state, Texas, they need some energy, and these guys don't need 10 gigawatts. They can probably sell some energy to these guys. Similarly, even other days when they have more, they can sell it to them. So the transactions happen all day long. Bottom line is, these companies, like energy companies, will have generation plants. They will generate power from nuclear or wind or solar or gas or sometimes coal. Hope not coal, but these clean energy generation, wind I mentioned. So sometimes there are other ways of generating energy, especially not in this country though, but there are some other ways like, bioenergy or other things that are possible. So geothermal is another one. So geothermal. Lots of other sources of generating energy primarily are these ones, right? Depends on, which location you come from. So you generate energy. You have to then, convert that into a very high voltage, something like 11,000 volts or higher. And then at a very high voltage, you transmit your energy from the generation location to the destination location. And the transmission at a very high voltage happens very efficiently. And this efficiency has to be taken into account. Otherwise, you will have energy loss. You don't want energy loss. And at that time, when you reach the destination areas, you down convert. You convert down from this 11 kV to something like a local 110 V, and then you distribute to your localities where people live, where industries are, where businesses have. So they need energy, you just distribute them electrical energy. So mostly electrical at that stage. Sometimes, these companies also are in the business of selling gas. And that gas and electric both get distributed to local locations. That's the entire pipe. That's the primary bread and butter for energy companies. Now, to enable this scenario end to end, from all the way from generation to the distribution end point, a major activity needs to happen. And that thing is monitoring. Monitoring of every single activity that happens all the way from the source location where the generation happens through the transmission and the entire transmission pipe all the way to the destination wherever it is getting delivered. You have to take care of every single action item that people have to do, machines have to do, transformers have to do, the pipes, the connections, the wires, the cabling, the cooling, the heating, whatever it takes. Every single thing has to be continuously monitored. Continuous monitoring. This is just critical for business. Otherwise, you will have no idea whether there is a gas leak or whether there is a fault or whether there is something else that is going wrong, something bad happening. You cannot detect these kind of issues or these kind of problems unless you're monitoring. And now you're looking at gigantic nations, right? Big countries, big companies operating on a national level. You have, ton of infrastructure, ton of things to monitor. And so this picture that you have in this example is on the lower left corner, which is this segment here, high throughput, parallel upload, or import and export. And now whatever this is illustration, it doesn't directly say that it applies to an energy company, but energy is a good example, by the way. It is a good example of information gathered from multiple sources across the board, all the way from end-to-end pipe, from source of generation all the way to distribution of something like a gas pipe, or something like electricity generation from nuclear, solar, wind, and thermal, all of the sources, hydropower, all these sources you have to detect. What metrics do you want to collect? And your first thing you do is just get all the metrics loaded up into some location and keep accumulating that data, because what you really want to do is to analyze and find out trouble spots and take proactive action on those items that can potentially cause bigger problems. You want to solve the problems immediately as soon as you can detect them. That's the whole purpose behind monitoring. That's the whole purpose behind an end-to-end pipe of a energy pipe, as I call it. It just could be transmitting electrical energy, could be transmitting gas. At every step along the way, you will have to collect metrics and put them into a cloud bucket like that. This one. Oh, died on me. So high throughput, parallel upload, multiple sensors collecting metrics about electric or gas or any other thing that you want to measure, and just upload those metrics into a bucket here. And that's the idea, the first step. You're basically beginning in a large scale computing and huge data sets is the scenario of usage. Why is it dying so often? And the idea essentially is that you want to first thing first, get everything that you want to measure collected and stored. So you have it here in the bucket somewhere, in the bucket stored safe. Trying like 3 times. Okay, I'm going to ignore it, open it again. So Shiv is suggesting a picture of something, new trade desk at our headquarters in Baltimore. And so this is your energy trading desk. Is that the idea?
Yes, Nilesh. This is a new trading desk. It's a 2-floor desk. So if you see all the traders and all, as you see, they have a minimum of 3 or 4 monitors, or probably even 6 to 7 monitors.
Nice.
Monitoring different factors, whether that is, I know God knows what all they do.
Yeah. I used to be working with a company called Enron before.
Oh, we have a lot of ex-Enron employees.
I know. The Enron project in India is done by me. The Enron Dabhol project.
Okay.
You know, heard of that, right? Did you?
Enron India, no.
Enron Dabhol project in Mumbai, long time ago. Like you were a child at that time.
Okay.
Yeah.
That's why I never heard about it, probably.
Yeah. So we'll talk more about that later, but that's a good picture. Thank you. So the idea essentially is, let me open it up again, is to collect metrics of a variety of different types and digest them, basically. And so people joke about this idea of large companies, especially people joke, my friends at Microsoft joke about this thing, which is, you have 50% of the company busy in collecting metrics. And the other 50% is busy in making dashboards. And so the idea is, who's working now then? If half of them are busy collecting metrics and other half are making dashboards, who's really working? That's the joke. So jokes apart, the idea is that these actions of collecting metrics and making dashboards, so you can make sense out of it, make meaning of the data. You have to extract sensible information outside and make use of that information. You can make use of this by analyzing data. And that's where the pipeline that it is trying to illustrate here is basically, this illustration shows you that you have to accumulate data that you collect from a bunch of different sources, to put them in a bucket, like that S3 bucket shown in the upper or left corner, this segment here, number 3. And then in the number 2, which is this segment here, you have a bunch of machines, the Amazon EC2 machines as shown here. The idea behind these machines will be, their purpose will be to read and write from the buckets and attempt to understand what is it that the data that it contains. What does it mean? To maybe able to draw an illustration, draw a visualization based on what that data suggests, to then identify patterns of anomaly. What is out of the ordinary? What is a hot spot in a gas pipe? What is a spot where there may be potential disconnections happening that might lead to short circuits in an electrical outage scenario? And so, whether it's gas or electric or any kind of a problem that you want to be able to detect, you can do that anomaly detection by collecting and measuring for it. And since it can be a large scale implementation, you need to be able to not only identify those problems, but also the law sometimes requires that you preserve that data for a long period of time, so that in case of an audit or in case of any other regulatory requirements, you can always go back and read what was the metric that was showing at a given point when some bad eventuality happens, accidents happen, a gas leak happens, or something of that nature happens. You can always go back and find out. Say, for example, you have a gas pipeline that goes from here to here, and it carries liquefied gas, natural gas. It is liquid mostly. And so you would like to make sure that this flow of gas is laminar and not turbulent. These are physics words. If you do not know, look them up. The idea behind laminar flow is it is smooth. And if the flow of gas liquid is smooth, it is going to reach that efficiently, and you are able to push through a lot more energy efficiently if the flow is smooth and laminar. If it is turbulent, you have a problem. You have to understand what push that this motor may be doing, or the pump that you may be running that is pumping this liquid gas. Make sure that this pump is not defective. That may cause turbulence in the flow of the pipe, in flow of that liquefied gas in your pipe as it reaches your destination. You may have seen large-scale pipelines of gas, at least have you heard of it, or maybe seen pictures on Wikipedia or YouTube. So gas pipeline, if you haven't seen, you may see something like this. It's a good picture. And this is probably a more realistic picture from an industrial perspective. So you have seen, these kind of pipes that are running through a factory. Similarly, you will have an example where, this may be a good one. Yeah, this is an illustration of a stock photo natural gas pipeline compressor. So pipes like this will flow from one state to the other, from Alaska through Canada through the state of Washington. There is a pipeline. There are these other pipelines that people are protesting and the president is deciding and things of that. You may hear these in the news. These things are constructed by energy companies to make sure that the energy flows properly. And that's what this company is attempting to accomplish for our people on the East Coast. Now, in this illustration, the idea is for them to be able to collect that metric and understand through what is known as big data processing. Now, what is big data processing? If you may or may not know, I would like to just quickly ask you, do you or have you heard of or used products like Hadoop or Spark for big data? Or have you seen these names at all? Or do you know of the idea of what I described the other day about NoSQL database versus SQL database or relational databases? You may have heard me talk about this versus the NoSQL database, where I mentioned Mongo. And I also mentioned these two as being a NoSQL database of some sort that help you deal with big data. My question to you is, are you familiar with this kind of a thing called Hadoop or Spark, or do you like to have a quick overview of what that thing is and how it applies to this illustration?
Yeah, Nilesh, let's do an overview. I've heard of them, but I've not experienced them in sense.
Okay, good. So I'll give you a short overview of what that thing is, because that's a good application that is really, really relevant to using and analyzing big data. Like big data can be really, really big. And so why do people use the word big data is the way I would like to begin discussing, and briefly give you an overview of what they actually accomplish for us. So the challenge of big data essentially is that you have these three things: volume, velocity, and variety. These three V's are the characteristics of the problem that is different from any other data storage problem. The problem that we are talking about are three things. One of them is the volume of data, the sheer amount. The sheer amount of data that is thrown at you is so big that it will not fit in a hard disk. It will not fit on the biggest computer you can buy. It will not finish processing in the 24 hours that you have in a day before new data will come into play and will fill up your hard disk again, and your to-do list will grow bigger than you can process on one machine, the biggest machine you can buy. That's the kind of volume I'm talking about. Second thing, the speed at which it comes, the velocity at which it comes. And the third thing is the variety, the different types of data that comes across. The sheer amount, the velocity, the speed at which it comes, and the variety that you have that you have to deal with. It can be enormous. So big that you cannot really fit into the biggest, baddest vehicle that you might have at your disposal. So for example, you have, say, a warehouse that is here in Seattle. And you want to basically, move the entire warehouse, move it to Canada, say, for example. And that's the goal. You want to move this to Canada, and you have an entire warehouse full of bags or some cement bags, say, for example, cement bags, right? You have a warehouse full and you want to move it from Seattle to Vancouver, British Columbia, Canada. And so now you have a fleet of cars, or rather I should say the fastest car you can get, a Tesla. You have a Tesla. Would you want to use the Tesla to just load up bags and just zoom through on the highway, go to BC, come back and take another round and come back and just do that? Is that how you recommend that we have a fleet of Teslas doing that operation? Is that a good idea to do it like that? Or alternatively, we take a train, like a goods train, something that looks like this. Oh, it picked up an Indian train. Oh no, I wanted to pick up an American train. What would it be called? Union Pacific. Okay, there we go. So yeah, this is a goods train. You can move the same thing in train that looks like this. And this can take your cement bags from Seattle to British Columbia, no problem. Which is more efficient? Is it this, or is it Tesla that you want to go and use? You can use both, but which is more efficient? Which is more appropriate from a business point of view? You have a fleet of Tesla sitting at your disposal. You also have a goods train, a train that looks like this, a luggage, whatever. I think the word goods train is an Indian English word. That's why the word did not pick up the right search in the image search. So a Union Pacific Railroad rail like this is at your disposal, and you have a fleet of Teslas. Which one would you use for moving cement bags? Is there a consensus answer? Do you have a consensus answer? What do you think is the answer? It's a train. You would not use a Tesla. Do you know why? Why would you not use a Tesla? You had it. You have a huge collection of Teslas at your disposal. Why would you not use it? Anybody?
How much does it cost to run the Tesla, and is it economical?
Tesla is free to go from A to B. Charging is free.
Yeah, but you still need a driver, and you need consider the damage is going to happen to the Tesla.
Yes. You're right.
The maintenance or whatever.
The way to think about this, you're absolutely right in thinking the direction. The way to think about it is, even though Tesla can be very agile and very swift and very fast, and a train might take like a couple of days to go from here to there, maybe less, but maybe a day at least. Tesla can go 3 times in that duration, go to Vancouver and come back, because it is quick and fast and all that good stuff. You still not want to use that, because you cannot, first of all, fit the entire warehouse of cement bags in one Tesla. You may need a fleet of Teslas, which you have, but still it is not economical to have it like that. Instead, the thing that you have to do is this. you have to deal with throughput, is how many bags can you push through a pipe that sits on wheels that look like this. That this is basically a pipe. You're fitting cement bags in those containers in the back of the train, and then the train moves. And so it is essentially a pipe that moves cement. And that's the throughput you want to accomplish. You can accomplish that in a much more efficient fashion if you use a train as opposed to small little vehicles like Tesla. And so the core idea behind using the biggest, fastest machine that you have, which today is Tesla as an example, or the biggest, fastest computer you can have, say for example, the most expensive machine you can buy today. So you can acquire a gigantic computer and have that computer apply its full power of processing and do the processing for the data that you seem to accumulate in your bucket. And the new data keeps coming in here all day long, nonstop at a gigantic velocity. And you want to make sure that you finish processing this data within a span of time, say 24 hours, before new data actually starts to come in. And if you are able to accomplish that, then this machine is probably okay. But in case of big data, the problem that the industry is seeing is that there is more data coming at it before it can actually finish processing the data that has arrived in the previous 24 hours. So the bucket is overflowing, your processing is not enough, and the machine is too small to handle that. And that is where clusters like Hadoop and Spark come into play. What you do essentially is something like, where did the picture go? Here. And so this illustration of EC2 machines in this picture, essentially these boxes collectively are forming a train that looks like this. It's actually acting like a Hadoop cluster. And Hadoop cluster essentially is a cluster of machines that collectively operate together to form processing as well as giving a file system for storage. So what you do is, as you receive your data, you put your data in the Hadoop file system known as HDFS. It is a distributed system of placing files. It is spanning across this entire cluster of machines that you have. So this picture will have individual machines. Each one of them will have some disk. That disk across these machines, a cluster of machines, is shared in this HDFS file system, which is basically the Hadoop's implementation of a file system that is tied to not one specific machine, but is associated with the entire cluster of machines, which means one or more machines can die, but your data is still intact. It is there. It doesn't go away. In fact, you can ensure that, if you have, say, 4 machines and you want to store your data, you will store your data in 3 places. And any new data comes along, you store it in 3 places. New data comes again, you store it in 3 places. And more data comes in, you store it in 3 places. Like that, you can improve your redundancy of data storage depending on where you save that particular content, in how many times you save it on different physical disks. And that's how HDFS is structured. Gives you higher availability of data and higher durability of data by spreading the work of storing that data in multiple locations. And you can increase the level of redundancy that you want. Like in this picture illustration, I'm storing it in 3 different places. You can increase that number to a higher number if you like, for a larger cluster. And by doing that, you basically improving the level of reliability of the overall file system. That's one benefit. The second benefit you notice is that, which is different from any other cluster that you may have seen before or heard of, is the idea of moving code to where the data is. So you relocate the code that you want to process, the processing code. Whatever you want to process, it is easier to move the code to where the data sits. On whichever cluster or machine the data is currently residing, you take your processing to the location where it sits. As opposed to traditional clusters, what they will do is that you have computers that are processing and you have some storage here. What you will do is this machine is going to process, so you read the data from the storage, and then you process, and then when you're done processing, you put the data back into the disk. That's how traditional processing used to happen. So you read from the disk, you process, and then you put it back to the disk. That's the scenario of a classic cluster, where you have multiple processing units and you have a storage location that you're sharing. And that's the old way of clustering, or the traditional clustering method. Whereas Hadoop clustering is the exact opposite of what we just discussed. The idea is you have way too much place to store data. So a bunch of different disks are available to your cluster, and more of them. And you have higher level of redundancy. So, three times, every copy is stored 3 locations. So you can have more disks here, for example. And a piece of data that you might have, let's say the data is ABC. So you want to store it here and here, and I should describe it differently. Let's say we have data, A through Z, all of it. So I'm storing A, B here, A, B here, A, B here, and A, B, C, D here, C, D here, like that. And so basically I'm spreading it out, making sure that every item of data, I'm storing it at least 3 different times. So my A through Z data, I'm basically spreading out across a bunch of disks that I have, across a multiple number of computers I have. And since now I have a bunch of machines, and most of them are storing my data spread out across underneath this thing known as HDFS, which is the underlying file system. Our goal is to not move the data, like in this illustration, to bring the data for processing, process it, and then put the data back in its location. We don't want to do that for a couple of reasons. One of them is that we are dealing with such gigantic amount of data, is that it is big as in really large. And since it is large, it is expensive to move data from the disk to a computer, from this disk to this computer. This moving of data itself is quite cumbersome, quite slow, and expensive on the disk and on the CPU. Why would we not avoid that? Instead of moving the data to the computer where you want to process, why not send our code that will do the processing to the machine that has the data already right there, local to the box? So if the data that you have, that you want to process, sitting in this location, in that upper right corner segment, then what I would suggest, instead of moving the data where the processing you may want to happen here, for example, you may want to move the data from here to here, but that would be a bad idea because the data itself is large. The code portion can be small. And so what Hadoop does, what Spark also does, is shifts the amount of code that you need to run on that particular data and move that code and have the code run on that box directly. So you schedule your execution of particular code segment. If you want to say operate on the portions C, D, as opposed to all the way A through Z, you would like to have that code run on this box, and this box, containing those 3 disks, which is where C, D is stored. If you want to run some processing on the segment of data that is sitting on, or rather, if you want to do processing on the segment of data that represented by AB, you want to run your computations and your processing on the locations, on the machines, which has those A, B segments of data. And so you will run your processing here and here and here if you want. Actually, you don't have to run it 3 times unnecessarily. You could just run in any one of these places, 1, 2, and 3, because each one of them will have the appropriate segment of data that you are interested in processing. So the core difference in big data analytics and big data clusters versus traditional clusters, in traditional clusters, what you do versus in big data clusters, what you do is you move your code and take it near the data, near where the data is. And that's how I should write, actually. So erase that. Move the code to where data is. And here, what you typically do is grab data, process, and put back data. And in this example, you move code. In this example, you move data. Oh, move. Yeah, you move data here. Yes, you move the data. The traditional processing is on a cluster. You have multiple machines, and multiple machines will have code running here. So if your data is sitting here, you will move the data to that location, process it, and then put the result back. That's the traditional clustering approach. Whereas in big data clustering, the idea is that you have, first of all, very big data. And so you would rather move code from here, just send the code portion over to where the data is and run the code here locally. Code runs locally and finish the processing, put the results back in the location. And that's just one half of the discussion in big data. When you're doing it like moving code to the appropriate location where the data is, you still have to then collect all that data back in a centralized location so that you can aggregate. In the traditional model, you already are doing it in a central location. You're grabbing the data, processing it, putting the results back. You already have in that location all the information you need. So you already get that result. Whereas in case of when you move the code to a destination, to a remote location, you have to do what is known as a map operation and a reduce operation. That's the classic way of describing these two things. The mapping operation is that you map out where your data actually is, and you then go to that location where your data belongs here. So you run the code in that location, and that completes your local generated result is available. Then you want to collect from all these locations wherever that locally generated results are and consolidate these results. Number 5, result 6, result 3, result 2, result 1, result 4. You want to basically collect these things together in some central location. So you're now collecting just the results, not the entirety of the data. So the results may be a lot more smaller than the entire set of data, and then you aggregate them R1 all the way through R6 to reduce to get to the final result that you want to understand from a map reduce processing. And that's the core concept behind your HDFS and Hadoop way of processing very large data sets. You break the problem, distribute that across multiple gigantic machines, send your code to run it on each individual location and act locally, act on the data that is sitting locally, and then get the results back in form of a reduce operation where you collect all the results and then make sense out of it. Applying a simple example to this problem, if you want to say, the very, very commonly used words is, this guy Shakespeare who wrote several things, Shakespeare. He wrote several items of literature. So all of his literature is available. Now, if you want to count how many times a particular word was used, particular word, like Shakespeare would like to use the word thou. That word he apparently seems to like. So if I want to count how many times Shakespeare used the word thou in his entire literature, I can distribute that task across a bunch of machines. So if I have a collection of clusters and I will assign the task to these 6 machines, I'll basically take the entire literature I have from Shakespeare, divide it into 6 parts, put them here in these 6 locations, and have each one of them collect this process to calculate the number of occurrence of the word thou in each of these boxes in 6 different locations, for example. And then I get a local result, R1, R2, R3, and like that, R6. And at the end of the processing, I would like to collect the final answer, which is a summation of R1 through R6. So the locally computed results of how many times the word thou was used in this location, like that, I'm aggregating that to get the final answer. The final question that being answered is, how many times a particular word was used by this person in his entirety of literature that he had. So that's how you divide and conquer a problem. You divide it into 6 different nodes for them to be able to process, and at the end you collect that data. This is a classic example of Hadoop data processing. There are a couple of more things to remember, and that is this idea of why do it this way. The reason that you would like to do it this way versus not the other way is one simple example. I think I mentioned again, I think in the last time when I mentioned this thing called relational versus NoSQL databases. The key difference in the two is what I mentioned, that we have a very structured approach to storing data. A structured approach, meaning you have something like if I'm storing the name, first name, last name, address, city, state, zip, then I'm bounded by these strings that I can fit in here. And I cannot go arbitrary and fit whatever I feel like in any of these locations. I have to follow a discipline, a schema, a standard structure. Whereas in NoSQL, which is what this Hadoop style databases will fit into, is that it lets you write whatever you feel like, write as you wish. But when you read, then you apply a schema. That allows you a flexibility. You can apply that schema at the time of reading, and that gives you the flexibility to store whatever you have, plus whatever else you might have that doesn't have a room for here. If you want to ask, say, the Boeing company to include in your corporate address book, include the fact that you have a bunch of literary works that you have created, like this guy created, Shakespeare. He wrote a bunch of literature artwork, and like some of you want to store that detail in your contact database. Can you do that? Can you ask Boeing to change the schema on a relational database and have that done in a corporate environment? They'll probably say no, absolutely not. Another thing is, even if they agree to do it, it takes a lot of time to change the schema. Even if they agree at a corporate level to change the schema, changing itself and incorporating it across the organization takes a lot of time. Change of schema is, although actually the action of change is very simple, the process of making a change in a gigantic corporation can be a nightmare. You cannot easily change the schema because you have to have everybody agree to it. Whereas in case of this style of implementation, the schema is applied only when you read from it. So when you write, you can store whatever you feel like, and you can basically store whatever else you want to store along with the standardized agreed upon schema you can store anything else. The benefit of this is you do not lose fidelity, data fidelity to be specific. You don't lose that. And what's the point being, what do I mean by data fidelity is something that I would like to illustrate with an example. Say, for example, if I am asking you, and by the way, you are a chef, not the DevOps chef, but actual cook chef. You're an actual cook chef, and I invite you to come to my Seattle home and help me cook, a pig roast. It is practically not possible to do in downtown Seattle because, a full pig roast is kind of difficult. You have to have, lots of preparations and, all the things you have to accomplish, which is possibly not possible so easily to do in an apartment situation in downtown Seattle. But if I do the same thing and ask you to go to my Snohomish farm location, in that farm you have agricultural space and lots of room and the yards and everything is available. There you can do a full pig roast in the open and have the whole pig ready for people to be able to consume, provided you have the flexibility to not discard any component of the pig, any part of the pig. Whereas if you want to cook this animal and prepare a delicious meal and you want to do it in the area of Seattle location in a small kitchen, you have to discard parts of pig. Parts of pig that you have to discard will include, the head and the tail and, some of the feet and some of the parts that you typically don't eat. And that I would make a similarity of this discarded components with the idea of data fidelity loss. Now, once you discard parts of a pig in a specific location, such as Seattle kitchen, you cannot even have a place to fit the pig's head because, you don't know where to put it and you don't know where to actually make a full pig roast. So you would like to discard that, and you basically, as a consequence, lose data fidelity. And that's what you do when you store chopped pig in a city-style kitchen where you have a place to store this portion of meat, a place to store the other parts of the meat that you have, and you have bins dedicated to, specific portion of meat, a specific part of body in that bin in your kitchen. And that's how you would see a professional chef in a city-style kitchen prepare. Whereas in a farm-style kitchen, the chef has the flexibility to deal with the whole pig, and there is no data loss, no fidelity loss. You can always refer to the whole pig because the whole thing is available. And that's the kind of benefit that you see when you have everything stored as it comes, right as you wish. The first thing you do when you receive a data from any location, like these guys, whatever throughput you're receiving from your sensors, in an energy pipe, in a gas pipe, electric supply sources, you collect all the metrics. You don't discard anything whatsoever. Just save the whole thing. Put that in the bucket. Put that in your HDFS file system. And now you can decide when at the time of processing, do you want to make use of it or not? Either way, you don't discard any input that you received. Whatever sensors are sending, you just shut up and save. That's the first thing. Shut up and save. Don't discard. Because if you discard, you are behaving like a Seattle area, downtown, city, small kitchen situation where you are forced to discard certain parts of the animal. You cannot keep the entire fidelity of the data being received. And that can be bad. It is bad because you're losing out on some of the insights that may be hidden in the data that you accidentally or by mistake or by stupid design lost because you never bothered to save it. And since now, these days, disk storage is cheap, and it doesn't even make sense to throw data away at all. And therefore, you have situations like this where companies are saving the entirety of their input data that they're collecting from a variety of sources and just save the whole thing as is. When we come to processing it in a nightly cycle, in a 24-hour cycle, we'll either use Hadoop or some other tool, basically big data tools. There are so many of these tools these days. All of them conceptually operate the same way with subtle differences. The idea is you don't want to waste any data that you collect. Keep it, use it. If and when you need it, you have it. If you don't want to use it, let it sit there. It doesn't go away. It doesn't cost you too much. Just leave it there. And that's the whole idea behind big data, is to just leave it. Now, another example on the same story is the idea of Expedia company, in which they have, I think, 8 petabyte of data collected. The data comes from situations like, if I go and buy Expedia.com, buy a ticket here, and I say I want to take a flight from Seattle to, say, Fairbanks in Alaska. And so I select a date and start searching for it. And I just did some, searches. So here we go. And so any transaction I'm doing right now is an activity that Expedia is collecting and is able to detect that I logged in and they're offering me this ticket and even a lower price ticket. It says only one left. So it just is able to now tell me that 74 people are shopping for flight to this location, which is Fairbanks, right now, and only one seat is left at that price. Is that a good idea for me? And so they are constantly telling me what other people are doing right now. And what you see here is actually big data in action, when it is giving me incentives, psychological incentives for me to go and click that button right then and there. And if I click, it will make me the booking for me. And so it says, save the return leg, and then add a hotel now and things like that. So it is able to basically drive me towards buying a ticket by collecting data from people like me on the internet who are attempting to book a flight on this day from here to here, and is able to give me real-time feedback on what other people in the similar boat are attempting to accomplish, because they are gathering click behavior, click metrics, or click stream analysis is what's going on. So for Expedia, the high throughput data comes from users clicking on Expedia's websites. Whatever people are clicking, they're just capturing the data, putting it in a central location, and have their processing pipeline, something like this. They have it in-house. They have a cluster, a Hadoop cluster, and a Spark cluster, and a bunch of other things. What they're really doing is, for every user that is sending them data, is to almost in real time come up with a recommendation that will entice that customer to make a purchase. And that action, what you saw me do when I go to Expedia, for example, was a real-time analysis of behavior of people attempting to buy something. And if I just walk out from that, you might see occasionally a pop-up that did not come right now. I was expecting to see a pop-up. Expedia. Let's go there again. Sometimes what happens is Expedia is able to detect that I walk away. And if I did, they might want to, give me a coupon to say, don't go away. Here is a $20 coupon to go buy that ticket that you intended to buy, provided you actually use that. Ticket and actually purchase that ticket right away. So they might do that, especially for places where you have a hotel involved. So if you include a hotel or a bundle, they're very likely to give you a coupon, and that coupon is generated on a real-time basis based on how many hotel rooms are left for those dates and how many other people are asking for it at that given time. And they're able to do that computation based on what they receive from the user's behavior as people click on those websites as they attempt to buy. And so they look at their inventory of hotel rooms, look at how many people want to use them, they have like 40 different websites, by the way. Expedia, if you go to the bottom, there are all these sites that you may have seen, which are Expedia partner sites. There are Egencia, Hotels.com, Hotwire, CitySearch, Online Shopping, Home Advisor, Cruise Ship Center, HomeAway, Travelocity, Trip, and Trivago. All these are Expedia companies, and they are collecting data across all these sites. I'm just showing you the Expedia example. You do the Trivago thing, they're basically the same company with a different interface. If I want to go Fairbanks again, they will be able to collect that data for people like me who are attempting to go to Fairbanks this weekend and gather that information and make use of, essentially in a fashion that drives more sales. So this high throughput in case of Expedia is coming straight from users clicking on those 40 or different 50 websites that Expedia company runs. And that's another example. Let me see if I can pull up one more example for relevance to Boeing company. The example would be this high throughput parallel upload scenario where ingestion of data is coming from your airplanes. Your airplanes are constantly generating a ton of data. They are sending it down to you. You know this probably. You are collecting the data that is probably applicable to your, so let's say, you have our nation in the US. So this is the US map. And in the country, you have a bunch of different flights flying from A to B, a bunch of planes flying across the board wherever they are. So these are the flights happening, and each of these planes will send some data about the machine itself, the airplane itself, as to what is going on, how is the engine operating, how much level of fuel they have, what's the temperature, pressure, all sorts of metrics that the entire plane will generate. They will send that data out down to the earth at where Boeing will be listening for that data. It will collect that data, and those planes that are flying at a given time across the nation. By the way, they do it globally. So I'm just showing you an example of all the that Boeing is flying at a given moment. Those planes are sending high throughput data back to Boeing. Boeing actually makes use of this data in a proactive fashion to address any potential problems or service needs that those planes might have. It translates to something like this. You have a plane going from, say, Seattle to New Jersey. For example, Alaska Airlines flies so coast to coast, and the plane is traveling from here, goes all the way up to this point, and at that point it detects that it needs a part. A part is needed, and so it sends that message that I need that part so that I can keep that plane flying. And so that message goes down, and that has to be captured by somebody on the ground, and that detection has to happen. So somebody has to not only detect that the part is needed, but also has to transmit that information to the New Jersey location so that by the time the plane reaches here, the part also reaches there. And at the time this plane is on the ground, they will replace that part, and the plane is ready to fly again. And that's the kind of scenario that you will see. And that's just a trivial example of how data is sent from your planes. And this is just a part example. There are a lot more metrics that I do not even understand, but they are there, that applies to flying planes properly at a global scale. And that data is collected by Boeing company so that they can actually maintain, monitor, and keep the planes flying all the time to help the customers that they have. Their customers are airline companies. Another example, and I think this is the last one for this big data thing. You have seen this, heard of this thing called Tesla. This thing drives on its own these days, by the way. So this thing, you will see, it drives on its own. It has like so many cameras around it that it is able to drive itself. The cameras that it has, it generates 10 gigabytes of data for every mile of driving. 10 gigabytes. That's the camera video feed that it accumulates, and it's able to drive itself. Now, with so much amount of data, it is actually impossible for all that data to be centrally stored. So you will see some data loss or data fidelity loss already. It is humanly impossible for Tesla to take all the video feed that it generates from the car and collect that and store it centrally in some location, like this S3 bucket, for example, or their Hadoop clusters that they might have. It is practically impossible because all you're dealing with is this car that you have. It has a 4G LTE connection, and it is running all the time. You have like 10 plus cameras, and you have like 10 plus cameras, and these are like about 10 gigabytes per mile of driving. So that's the level of detail that you collect and accumulate when you just drive a Tesla for 1 mile. You collect 10 gigabytes of data. How in the world is it possible for every Tesla car to send 10 gigabytes of data through this LTE connection to a central location owned and managed by the Tesla cloud? It's not possible. Practically today, not possible. You cannot push 10 gigabytes for every mile of driving. It takes like less than half a minute to drive a mile in a Tesla. So not possible. So the thing that I mentioned, this idea of don't discard anything, actually, I would like to say that today with modern technology, it is actually not possible anymore, given the amount of data that we are generating. Is that we are now going back to the situation where we will eventually discuss and hear big data people talk about, because today big data people talk and tell you that don't discard any data because you don't have to. But honestly, with examples that I just showed you, with a Tesla example of collecting so much video content around its surroundings, that you cannot store that data because you cannot even receive it. Forget about storing it. And that's a problem that you have to understand, that not all data can actually be received. You have to discard because it's not, the pipe is not fat enough. This pipe that we are talking about, this car has this 4G LTE connection, is not wide enough, fast enough for about 10 gigs of data to be pushed out to the Tesla cloud in a mile of driving. Impossible. Cannot do it. And therefore, you have to interpret what makes most sense to keep, what makes most sense to actually preserve as opposed to discard. Because at some point, you have to make that decision to discard, and there is a request for break. So I will do that after a few sentences. So just let me conclude the thought of this driving and sending data to a central location. This idea that this car is driving. Let me see if I can pull up a picture, or maybe, you know what, let me take a break. And in the break, I'll do some searches to find out what data actually a Tesla would try to preserve and what it has to discard. I'll pull up some examples to show you, because it actually has to discard. It cannot keep track of all the data it accumulates. Not possible.
Nilesh, one quick question.
Yes.
Isn't there an importance of the data value also there? Because let's say like a black box or a crash or something else.
Yes.
To store data or transmit the data in case of an error.
Yes.
So it's not just saying, hey, we cannot
black box. You're right. There is a thing called black box, which is flight data recorder, right? So it's called Digital Flight Data Recorder. Where is that? Digital Flight Recorder. So this device or this kind of a, what is this flight data recorder? Underwater locator beacon. So this box is not really a black box, but this is called a black box. Is the idea where you keep critical data about the plane in a critical. It probably has it. Every plane will carry such a thing, and you keep critical flight data inside this in a local location. And this is old technology, by the way. This is not new. This technology still exists. It is still in use. However, there are extensions of this technology in which now that planes can actually transmit data, they also transmit the data out to local ground locations. So flight data recorder, this device is actually tremendously useful. I'm not discounting it. But now that planes have the capability to send data out to the ground while flying, this is important, but not the entirety of the solution available. The entire solution space has been expanded to include transmissions from the plane to the ground, which supplements the information that can be stored locally. And that's where the purpose of this is somewhat reduced, given this has been in use since 1967. And those days we did not have internet and all that good stuff. But today we have it, so planes have evolved. This is an old technology, right? So let me now take a short break, and I will start searching. Timer will start right now, and we will resume after the break. And in the meanwhile, let me search the relevant idea that I had in mind about what needs to be kept and what can be discarded. I guess you're back. Let me check. I think you look like you're back, but I'm not sure. Hope you can hear me. Yes. Testing, the sound is working. I don't see.
Volume is coming very low, Nilesh.
Okay, how about now?
Much better.
Okay, good. So I was just checking if you guys are active, and I see that you are, which is goodness. So let's continue. So I want to what I want to be able to do is give you that link that I gave you, and so welcome back, David. Hey, good to see you here. Where are you, David? There it is. So yeah, good to see you, David. And what I was talking about before we took a break is this video that I just posted. And you will see if you play that video is the idea that it cannot humanly or rather practically send the entire feed of data to a central location because it is impossible. The amount of data it accumulates, it is not able to basically send all that detail. So if you look at what it is sending is the appropriate information about some obstacle around it. Like for example, this left rearward vehicle camera and the medium range vehicle camera and the rearward vehicle camera. There are cameras all around the car, and it's able to detect appropriate. Yes.
Can't see your screen.
Oh, sorry. Thank you for pointing it out. I was assuming that I am looking at the screen, but thank you. So now what I did was click that video, and you will see how it is able to. Let me zoom to a point in the video which will show us exactly what I'm talking about. Oh, you have to first see an ad.
Let's face it.
Shut up and listen to the ad. Oh no. I cannot tolerate ads. No, shut up. And so this ad came because I just went to Trivago website, and you remember, right? So Trivago's ad shows up. This is again dynamic, and you can see a real live implementation of how you do that. I can talk about in next example I want to pick up, which is, where is that? Ad serving. So this example we will discuss very next. But I want to conclude the current one we are talking about. So the ad serving example you're looking at, this Trivago is going to give us, before it will let us read and listen to the Tesla video I want to talk about. So there is apparently no way out for us but to listen to this 7 seconds of Trivago guy talking about hotel. Okay, thank you. Now watch this video. You will see the car is driving by itself, and it is accumulating those screen segments. If you look at in the upper right corner, it is detecting motion in a green square, green rectangles. Look at the green rectangles. That is where you see activity that needs to be taken into account as you drive the vehicle. And what Tesla does is gathers the spots that it detects, like the green and the blue elements. And these information about those obstacles is what it transmits, stores locally, and transmits eventually to a central location, so that then Tesla can analyze how the car is driving and if it can improve upon its qualitative performance on the road. Driving like this is scary, of course, as you can imagine. It's just put your foot down, put your hands down, and it drives by itself. It is nightmarishly freaky, but it works. and it works magically. I mean, that's the beauty of this car. But the bottom line, from a data collection perspective, it is humanly impossible, practically impossible for the Tesla car to send all of the data it collects. So it is limiting itself from sending only the relevant data. That defeats the old discussion that, big people have been talking about big data and don't discard anything. But the fact is, you have to. It is physically impossible to send 10 gigabytes of every mile of driving. There's so much collection of data happening here in this example. That's the point I wanted to talk about. With that, I will pause this video halfway through and resume our discussion, which we're having on that sheet of illustration. And I want to conclude the discussion here. Essentially, is the newer evolution towards big data is happening towards relevant data, not the entirety of data, but only the relevant data that you actually can, because there is so much data being generated at the endpoints that even if it is a high throughput injection pipeline that you might have, it is still not enough to actually fit in all the data that a collection point may want to send you, especially given the large amount of video feeds it collects in the Tesla example. And with that, I want to switch over to the other topic and discuss this idea, which is ad serving, advertisement. And I'll begin by showing you a real life example. The example I want to talk about is something that you may or may not have seen today, or maybe in the last couple of days, is that I am experimenting with advertisements. You will see that this is a screen where I'm experimenting with real live examples of Cloud Genius advertising. This is like first time I have spent $82.99 on advertising on our next bootcamp. I'm not sure if you have seen this ad or not, but I am doing it to anybody who is visiting the site once. Have you, by the way, let me ask you, have you seen Cloud Genius ad in the recent days?
No, I haven't.
No, I have not.
Not? Anybody seen it or not at all?
Nope.
No. Okay. Strange, very strange. But actually, it is actually really strange because the ad looks like this. I'll show you how it looks like if you may recall. This is what might show up if you go to CNN or New York Times or all the big publishers. If you go to them, you might see advertisements like this. Now, this is a simple advertisement that I have just started playing in the last couple of days, and that is conceptually what Trivago did when I visited here, trivago.com, and I clicked. Just to illustrate you the point, it placed a cookie on my machine. And based on that cookie, when next time I went to see the Tesla video, it injected itself in the middle of it and made me watch Trivago ad. I disliked it because the fact that it is an advertisement, and I know that everybody dislikes advertisement, but I'm just experimenting with ads right now, and that's the reason why I am running an ad campaign, as you can see. But and it started like in this time frame. So like a couple of months ago, I ran it here, and then I'm running it again, and like that. So it's a very, very lightweight way of running a simple ad campaign based on cookies that you place, like what Trivago did on my browser. And as a consequence, you see that there is this tracking pixel that they have put. And this was one pixel found on trivago.com. That Facebook pixel has been applied to my browser based on my visit to this website. You can detect pixels like this placed by a variety of sources, and you can go to Cloud Genius site and also detect pixels. Same way, you can detect that I have placed a cookie on every visitor's computer, and that cookie shows up like here. You can one pixel found on Cloud Genius website. The pixel ID number is this, and it is basically tracking the idea about people who visit here. We place a cookie so that we can then track the behavior of that user. That's the core idea behind advertising. So now with that understood, by the way, this idea of advertising is called, I don't know what that no was. So something was no on David says no. I don't know what that was, but I see that no and I do not understand. So please explain, and I'll proceed with this discussion. So I will download it locally like that and open it up on my desktop. And it is right here. So let us try to understand what a typical ad serving solution will do. So before we talk about ad servicing or advertisement servicing, we have to understand who are the players in the game. There are three types of players in the advertisement game. One of them is the advertiser. The second one is where the actual advertisement shows. And the third one is the middleman. Three types of people. End users will see the ad. They see the ad. They see the ad where? That where location is the location where they see the ad, and that thing is called a publication. A publication is something like CNN.com or New York Times. That's a publication, and that's the location where you are serving your ad. Now that's one entity, the publication. The second entity is the advertiser. Who is sending the ad? Or I should say placing the ad. That's the advertiser. So in this example will be Trivago or me or those guys, the advertisers. Those are the people that spend money. They spend money and they place an advertisement. These guys are serving the advertisements. They are the publications. They make money by putting the advertisements and serving them through CNN.com. So if I go and visit CNN.com, do I see an ad? You bet. I see quite a bit of them, actually. And so let's see, what do we see? I don't see any ad here, but let's go read something. I might see an advertisement coming up somewhere. And here is Expedia advertisement, showed up right there. Why did it come? It came because I visited Expedia. There is a last minute cheap flight deals coming up. And that's what you're looking at as an ad placement. And I can shut this guy up. Okay. So the idea, let's go see another browser. You will not see Expedia ads in that browser because I did not visit that thing, that Expedia.com in this browser at all. So if I click here, I may not see Expedia ads. I might see CloudGenius ads because I have visited CloudGenius website on this browser. So you might see CloudGenius ad pop up somewhere along the way. If I see it, I'll show it to you. But I did not see it. And so I'll try to see if I can find that ad. It's not so easy to find because there are lots of logic that goes along in placing an advertisement and lots of transactions that need to happen. And I'll help you understand what goes under the hood as we discuss this illustration shown here. But before we get to the illustration, I want to talk about the third party here. The third party, this is the first party actually. The people who place an ad are the first party. And the second party is where the advertisement is actually shown. Is like CNN.com or NY Times or things like that. That's where your ad is shown up. There is a third party in the picture that you don't see, but that is very critical in the entire game. And that third party is companies like Google or Bing or Yahoo. Or there are other hundreds of others, by the way. These are some of the top ones. That's the kind of solution that these guys will implement, is what is shown here. This is the solution that will actually place advertisements for your advertisers. So bottom line, there are three players: advertiser, publication, and the middle people. These middle people are basically large companies like Google, for example. And what these guys do is pay them money, give them the ad. And what they will do is pay a portion of money, like a little dollar, small dollar. This is a big dollar. And the portion of this goes to the publication, and then they give them the ad. This person will use a service from this company. This service company is going to give them a service called the ad service. The actual serving of the ad is going to be shown here in the publication. And other people on the internet who read that publication will see the ad. That's the entire game, end-to-end game. If you look at from the advertiser's perspective, you want to show these ads to these people, you want to target them, and you want a middle company to orchestrate illustration of advertisements injected into the publications themselves. So here is where I would like to see my ads showing up. So that's this picture is going to discuss. We'll discuss this picture now in terms of understanding what are the elements to go along that will make these parties and the advertiser, the publication, and the middle people, like Google, for example, Google, Bing, Yahoo, like that. Those people, what do they do in terms of making sure that the entire business of advertisements runs according to the need of the industry? Industry requirements are very simple. There is an advertiser, they have an ad in mind, they have a need, they have a target, and they have money. So they have advertisement that they want to, satisfy that need, to provide a targeted advertisement to the target audience, and they are willing to spend money for that. And so that's the need of the market, need of the industry. Now, it is very difficult for any advertiser to directly approach a ton of publications here, CNN.com and all those guys. So it is very difficult. So, but it is these middle people, like I mentioned, make it easy for advertisers to advertise. And I'll show you what it means. I'll show you with real live examples of a running advertisement that will give you a very clear perspective on what's going on. So I'll begin with a simple example of a AdWords campaign that I'm running in Google's ad serving engine. And right now I'm seeing a notice limited by budget. So it is not running right now, primarily because I have put a limit of $10 every day as a budget limit. And looks like it has crossed that limit with 91 clicks. And so the cost per click was 91 cents per click. And so today it reached that boundary. And so $10 spent. So the ad has been stopped. That's what's going on. Why I did not see any Cloud Genius advertisements on a display remarketing campaign. And That's the reason why when I attempted to look for that advertisement, I did not see. However, the idea behind this is the display network, where I want my advertisements to be placed, is a collection of publications that are here. So you see a long list of example sites where Cloud Genius advertisement was shown in the matter of last couple of days. And those sites happen to be Capital Hacker, India Times, The Guardian, The Mobile Play, Professor Messer, Politico, News Blur, God knows, lots and lots of these guys. It is humanly impossible for me to go and interact with these 91 different placements. There are more than 91 probably, because this is anonymous. So this is a display group. And so some of them are anonymous, they're hiding, but they are there because they don't want to disclose who they are. They still want to advertise. And so the advertisement is shown in multiple places with about 91 clicks. As you can see, most of the clicks came from mobile app called Yellow Booster, Clean Boost. I don't know what this thing is. And these are 14 clicks came from here. 6 clicks came from YouTube. 3 clicks came from super bright LED flashlight. What is that? And solitaire, somebody's playing solitaire and 2 of them are clicking on it. And so people who are seeing the ads, I'm able to reach them based on what I see as a report coming back to me, and I have put budget limits. Now, if you think about from a perspective of an advertiser, this guy, in this example, me, I cannot reach 91 companies and have them run a campaign at the cost of $10 per day. And so therefore, this middle entity comes into play. Company like Google is helping me run a ad campaign across hundreds of publications and is able to run a aggregate statistic of 29,100 impressions of the ad, with a click-through of click-through as in number of people clicking of 91 out of 29,000 impressions. And the cost per click was 91 cents. And the overall expenditure that I have in the last so many days, I think about 3 or 4 days, is $82. Maybe 7 days is about $82 is the expenditure that I have incurred, and I have to pay them this money because I have spent that money on advertisements. Now, what does this boil down to from an infrastructure perspective, from a cloud perspective? That's what we want to discuss here. So now, from this perspective, in the Google's advertisement serving cloud, let's see step by step what they have to do under the hood to build out such an infrastructure where an advertiser can actually send advertisements to the target user. So imagine a target user could be anybody on the internet that I want to target as an advertiser. So I would look at this person, the visitor, who is going to visit some site, some location, some publication at some location, and they will be watching something, reading something, and they will be unfortunately interrupted, because that's the way advertisements work, is through interruption. And that's one of the reasons I personally don't like to advertise, but I have advertised. Right now I'm advertising it just to see how bad it can be, or is it any use to advertise. That's the real thing I'm trying to study, is it really useful to advertise? And that's what I'm actually studying. I know advertisements are really intrusive and people dislike it. You saw me hating that Trivago ad like crazy. And so that's a matter of fact. So people don't like advertisements at all to begin with, but people have to live through it, unfortunately. And that is the unnecessary, unfortunate aspect of advertising. It's the nature of the beast. So this guy, visitor, is watching some content. And within the context of that content is this advertisement, which is either an image or a video. An image would be something like, let's go see here, CNN, and you will see some advertisement popping up. Like, for example, why is there no ad showing up? There it came. So you see the ad came later. Ad came a little bit delayed on this network for Expedia ad. You can see under $200, this ad choice came along, but with a little bit of delay. And that delay is the reason why it comes from a different location, not CNN.com. This advertisement, this portion yellow banner, does not come from CNN.com. It is just a placeholder. This frame, this yellow frame, is a placeholder frame. It comes from a different site. Let's go see where it comes from. So right click and copy the link address. So if I copy the link address and see where it goes, it takes me to the destination. That destination happens to be, of course, Expedia. You will see that it is going to Expedia because that's where I would like it to go. But let's break it down. It doesn't go directly to Expedia, by the way. It goes through some network. That network is called DoubleClick. And if you look at the network, it is some parameters, some signature, and then advertisement URL, which is also DoubleClick, and then some more parameters and more parameters and more parameters, and then a pixel. This pixel is going to measure who's clicking. And let's cut some parameters again to see the link. The link goes to Expedia flight deals. There we go. So let's go read the detail around it. So here are clicks. Here is the ad URL. It takes from DoubleClick, goes to another location in DoubleClick. DoubleClick.net is a Google property. IMP Desk is a image pixel click, also owned by Google. The last line, line number 4, takes us to Expedia flight deals. And the parameter being passed is infectious remarketing display flight. And this is a indication of remarketing. Remarketing basically means market or show the advertisement to somebody who just visited you like a couple of days ago, maybe this day, maybe today, maybe yesterday. Recently visited people, you want to show them again, remind them again, hey, you want to buy a ticket to Fairbanks, Alaska? Come on down, buy a ticket from us. That's the idea behind remarketing. And Expedia wants to do that. They want to infectiously remarket to people who visited them. That's the remarketing display. And this is the deal that they have. So if you can go to that location directly, go straight to that Expedia deals, you will see the deals without all that jazz that you see when you visit that through a remarketing link. What we are doing here is going through jumps of number 1, number 2, number 3, that takes us to number 6 eventually. And that linking is happening through this reference, the yellow banner that you have. The actual image that you have here, the save image address, which is here, copy image address. If you copy that, you will see that this entry is not line number 6, but something different. What is that? It is coming from a site called 2MDN. This is another Google property. This Google website, 2MDN, is serving this image object from that folder location. And that is essentially an indication of the yellow banner that you see, that is indicative of a banner ad that shows up like this. This is just a picture. It's not clickable. You cannot really click anything here. Just an image. That's what pops up here. It comes from a different location, which is this location, not Expedia. The link to that goes ultimately to line number 6, but flows through Google's network in multiple clicks. And then you're able to reach the ultimate goal. That way, Google is able to monitor who's clicking and able to charge the appropriate advertiser on a per click basis. So translating back to what you saw in this example, in a campaign on a per click basis. I have promised that I will pay up to $1.05. And that's my maximum bid, maximum cost per click. I agreed. I can reduce it to something like 1.04 if I like. It's just gimmicks. You can adjust the cost per click you want to pay. And you can also change your overall budget. My overall budget for this particular campaign that I'm running right now in the display group, my overall budget, I have set it to be about $10 per day. Let's see that $10 per day number. Where is that? Ad group and limited by budget group. Where is the budget amount? Settings, ads, extensions. I'm missing the number, the top level number, $10 budget. Yeah, there it is. So top level, my budget per day is $10 per day. I can make it higher by going to a bigger number if I like. If I have more money I would like to spend, or rather I should say, I would like to waste. Basically, it's a waste. I find advertisement quite a waste. It doesn't actually translate to something useful. And it's actually annoying to people. But that's just my current way of thinking. I might change my thinking, but my current thinking is advertisement is a waste of money and is annoying to people. But I just want to experiment, and that's why I'm doing. So that I'm also not just doing, but showing you how people advertise. So back in this picture, this poor guy, visitor, who's getting annoyed, but he has to see that advertisement in form of an image or a video that is obstructing him from seeing the real content that he or she may be interested in. Now, where is this image coming from? It's coming from another location, the CloudFront location, for example. It's a content delivery network. So this CDN translates to this item, to MDN, for example. That's where this image comes from, this image number. What are the flight picture, yellow object you saw? Wherever you saw this item is coming from the content delivery network, which is picking it up from some static files repository, meaning another bucket of some sorts. In this example, S3. So it is picking up that thing from that location and showing it through some kind of a content delivery network to show the visual of the yellow banner. And then when people click on that, that generates a different click that goes to line number 1, then 2, then 3, and then to line number 6 to eventual destination, which happens to be an Expedia ad. So you will jump through hoops to get to the point where you really want to go through the advertisement. And those hoops are these intermediate hoops that eventually land you to line number 4. When you click on the advertisement, and when you do, what happens next is the click-through request comes in. This has to be, transmitted through some kind of a load balancer, and then the actual click-through servers will handle that. So these click-through servers are essentially a scalable, auto-scalable group that will look at which particular advertisement was clicked, keep track of, and pass along that request in your log. So click-through log files will keep track of who clicked on which ad, and then allow the traffic to go forward to the appropriate destination, which happens to be, in this example, line number 4. The traffic will go to Expedia, but before it goes, it needs to keep track of that through a log. And that log is kept right in your bucket in a repository. Now on the upper right corner is an Elastic MapReduce, which is basically a Hadoop cluster in operation that scales, makes itself big on demand. If it needs to go big, it can grow big. If it does not need to go big, it can stay at the minimum possible size it can. And that is using Spot instances. The idea behind this Elastic MapReduce or Hadoop cluster is going to basically be processing the log entries that you will accumulate as users click on advertisements. That's the purpose of this EMR, Elastic MapReduce Hadoop cluster, which is basically doing data processing on big data collected in these buckets that come through click-through of people clicking through on advertisements. So that's the lower half of this picture. The other half, when a person actually clicks on a real advertisement, what you want to be able to do is have that person, this visitor, you need to be able to not only show them this yellow object, like you see here. This object is just a yellow picture, like you see in this link in Slack chat, that picture. It's just a picture. There's no link here. But corresponding to that link, you will see in this section, lines number 1, 2, 3, and 4, if you go back to that original advertisement and try to collect the entirety of the link, so copy link address again, and then go examine it again, you will see what you see in 1, 2, 3, and 4 is what you see in line number 7. The same thing, except not broken down. So the same 1, 2, 3, 4 combined is line number 7, and this one click is what is generated based on what you see in this segment, which is a link to the advertisement resource. An advertisement resource is the target where you want people to eventually go when they click on an advertisement. Now that detail has to come from the advertiser, the people who are paying money so that they want the visitor to land on the Expedia website. So Expedia here is the advertiser. In example that we are looking at, Google Ads is the advertising middle person. This middle entity that I talk about, Expedia is advertising on Google network. Google is generating a link, placing it in CNN magazine, the publication, and I am looking at CNN. I want to read CNN article, but I am presented with this yellow object for me to click on because of remarketing. Primarily, that's what remarketing does, is entices people to come again to your website because I know you want to buy a ticket, don't you? Don't you want to go to Fairbanks this weekend? Yes, you do. So come on down and come and click on that yellow thing. And that's the thing that you will see when I click on this link. Actually, like this, it opens up that link that takes me straight to that Expedia site. And it tells Expedia that it's a remarketing effort. So that's US, OLA, infectious, remarketing display. That's just Expedia's way of keeping track of the advertisement as to where this user is coming from. And then it is able to show me appropriate flight deals on this page and is basically able to entice me into buying a ticket, which I intended to buy. So it is keeping track of user behavior like this by using help from Google in placing that advertisement in Google's network. So on the back end of Google's websites, you will have something like a DynamoDB or maybe Google's implementation of a NoSQL database, which stores profiles of different advertisements. And through that data store, will these ad servers actually construct that yellow object that you see here, this item will be constructed. It will not only contain this picture, but also the hyperlink corresponding to it, which looks like line number 7. That link has to generate, which translates to eventually taking people to line number 4. That link has to generate like this, like line 7. And that is what that collection of ad servers is going to do, which will allow rendering this advertisement, not only the picture part, but also the link to the resource, which is what Expedia wants people to see. And that's what you see when a company like Google will put infrastructure like this on the back end to have the upper upper left corner, these black segments here. They are responsible for ad serving. The black items on the upper left corner are responsible, these segments are responsible for ad serving, meaning showing this yellow object all inside CNN.com. And the other segment here, this side, in the bottom corner, or rather, even including parts of S3 bucket, the white colored part versus the black colored part. This bucket is used for both purposes, not only for ad serving, but also for click-through. So the click-throughs are happening through here. So when people click through, the actions will go through this. Logs will be created and will be kept here in the bucket. Whereas this portion, the black portions, are actually generating the yellow objects that you see, the advertisement that you see here. And you can probably see similarly on other sites. So you can go to New York Times, for example, and you will also see Expedia ads right here and somewhere in this. Very likely, you might see an Expedia ad pop up just because I visited Expedia. No ads. Oh, there it came. I saw something yellow. Trivago came there. Yeah, so it's Trivago. And same thing, same idea again. So Trivago ad popped up because it probably bid a little bit more than what Expedia did, like a cent or two more, but slightly more. And so on this New York Times, you see Trivago ad, and that ad is structurally very similar. If you now look at this Trivago's advertisement and look at the frame, you right-click on it and see the items. Oh no, not this. Hold on, let me show you that. Right-click where it's coming from. No, not here. Click back. Right-click. It's not constructed like an image advertisement, but more like a HTML advertisement. That's why I'm not able to grab that link easily, but I will get there. Hold on. Inspect. And there it is. So there is this static image URL. You can edit the HTML and grab that URL from there, which is this one. So you see that image, copy it here, bring it and paste it. And let's go analyze it. It is coming from doubleclick.net, and it's an image asset that looks like line number 5. Let's open it up in a browser directly. That shows you this image of whatever that thing is. And that's the image that you see in the advertisement here in New York Times for Trivago on Sarasota, that location. And the link corresponding to that will be a hyperlink, which is somewhere I think will be embedded in a JavaScript. So I can get to that if I need to. But bottom line is that what you saw in two examples, this company called Trivago and this other company called Expedia, both of them using Google Ads as the middle company to place advertisements on two publications, New York Times and CNN. You saw Expedia showing ad here and Trivago showing your ad here. That's what you saw in real life example when I came and see here and see here, I see these guys. And the reason they were able to show me that is primarily the idea called remarketing, which is to target a user that just seemed to have visited you. And so just remind them again to come and visit because you want to travel to Fairbanks this weekend. And that's what they're doing. So that's the overall picture from a usage perspective. These are the advertisers. These are the publications. And this is the middle party. And here's the poor guy who has to see the ad, unfortunately. And that's what is the nature of the beast. So bottom line here, the black segments, which are the portions on the left side of the screen, are responsible for serving the advertisement to you, to the user. And on the right half are the segments that will respond to your clicks on the advertisement when you do. Now, this picture does not show you at all the element in which an advertiser is coming in and placing an advertisement. That part is not listed at all here. that piece is a separate piece of puzzle that actually populates the repository with the image that you want people to see and the language that you want people to read when they see the ad, and the target profile, the corresponding remarketing cookie characteristics, and all those metrics are not shown in this picture. What this picture does not show you are the things that relate to an advertiser. Like, for example, Expedia. What Expedia needs to do is to produce that yellow object, that yellow thing, which is, where is that thing? The yellow thing is here, this line. That's the yellow thing that Expedia has to generate in-house. So they will create this creative article, creative artwork, and it talks about top flight deals under $200, incredible, whatever, blah, blah, blah. So that picture has to be constructed by Expedia. What they need to also do is provide that yellow object in form of an image. They have to provide a write-up as to what exactly will show to the end user and send that over to Google. And Google will have to take that input from the advertiser and store it somewhere in a central location, in a database. They will also take money from them. They'll take some limits in terms of how much you want to spend. They'll take a remarketing cookie. So the cookie and the logic corresponding to that, I'll talk to you more about in just a minute. The idea behind who should be the target. Like, there are a variety of ways of targeting the end customer. So you have to understand that from the need of the advertiser, and then have this company, Google, understand your target audience. And then once you understand that target audience, that you are able to then place cookies and place the ads that you write up using an image that you provide, using money that you provide, providing, setting a budget limit to how much can you spend, how much do you want to spend, how much do you want to pay for a cost per click. Every time somebody clicks, how much I was willing to pay, 1.05. How much I actually paid, 0.91. How many clicks, 91. Because my budget limit was $10 per day. And I'm just experimenting. Expedia has like millions of dollars of spend money on advertisement annually. So they have a larger budget. So they're able to play with it a lot more. I'm just experimenting. So my budget ran out of the day. So my ads are not running right now. As you can see, it told me that your ad is not running. So when I go to that same interface, which is here, I see that they have stopped my advertisement for today because I ran out of money. So it tells me that all campaigns limited by budget, boom. And so it stopped. But that doesn't bother me because I don't really care. What I am really doing is experimenting. Now let's talk about the remarketing thing, right? There are several ways of identifying a target audience. One of the ways that you can do in the most effective way for my situation is to target a small set of audience that have interest in Cloud Genius or might have interest in Cloud Genius. That's how I'm basically targeting. So what I do is people who come online onto our website and provide their email addresses, I assume that they are the ones that are interested. Otherwise, why would they provide their email address to us? And with that assumption, I treat those people as potentially interested. And when they indicate their interest by expressingly opting in to our site and providing their email address, at that time, we set a cookie on their browser. And that cookie is represented by a tag manager. The tag manager looks like this. It's opening up. So when a user visits a site, you will see that a cookie is placed right there. And there are actually 3 cookies that I place. Here are the cookies. There is a Google Tag Manager cookie. And there is a remarketing tag and a conversion tracking tag. So 3 cookies placed on that website in the user's browser. If you now look at the same thing very, very succinctly and go open a different browser, for example, and in there you want to clean out all the cookies to begin with. So I'll just stop this, go preferences and privacy, and clean all the cookies that I have. So clear it out completely and clear all the cookies, gone, no cookies there anymore. That's good. Now let us go open the site again. Fresh new browser, no cookies. Now I'm placing the cookie, as you can see right now, it's happening. And I just placed, I think 2 or 3 cookies from the Cloud Genius website onto this browser. Let's go see them. So preferences, and there is a cookie from Google. There is a cookie from YouTube. There is a cookie from, oh, lots of them. Oh man, other people also placed cookies. So YouTube cookie, Google cookie, Push Crew cookie, Cloud Genius cookie. How many of them? So we got 3, 4, 5. Oh man, I'm increasing number of cookies there. So 1, 2, 3, 4, 5, 6, 7, 8 cookies. The 7 cookies. 7 cookies from Cloud Genius. Double click, that's Google cookies. So we have got 1, 2, 3, 4. Facebook has 1 cookie. Cloud Genius has more cookies. 1, 2, 3, 4. And then LinkedIn has a cookie, 1, 2, 3. Ad network from Google again has more cookies. LinkedIn has more cookies, 1, 2, 3. So bunch of people are placing their cookies on the browser, on a fresh, brand new, clean browser. Remove them all of them are gone. Visit the site again, refresh, and you see the cookies come back. There you go, popping up, filling it up. So you're placing these cookies basically are a placeholder as a tag. You can see this idea of tagging a wild animal as they go, let go in the wild. Before you let them go, you tag them so that you can track them. The same exact idea is what this thing is. When you have a wild animal, you catch them, you tag them, and you release them in the wild so that they can go where they want, but then you know where they're going. And that is exactly what the idea is behind this concept of remarketing. When you have a number of users that opt in and visit your site, you want to be able to understand that those are the people that are potentially interested in your site. So you want to place a cookie there. And once you have a cookie placed, this idea of remarketing is what you see in this example here, where I'm doing that remarketing, and I can even go see some demography of people who visit our websites. And you can see that people who visit our website all the time, for example, let's see the demography. Apparently these people are all genders, all segments. Where is that demography? I wanted to see remarketing demography. And I'm on the wrong segment. Hold on. Let me go display remarketing. And then segment. No, not here. It's probably in this segment. No. I think the shared library, audiences. Yeah, so this is, I think, my audience. So the audience is those people who have recently visited our website in the last couple of days are about these guys. So we have 2,800 people who have seen the website in the last couple days, I would say. And that is generated automatically based on the cookies we place on people who were visiting Cloud Genius site on a search result, coming to us from YouTube, coming to us from other locations. And so basically this number that you see, the 2,800, is the appropriate number of people who have landed on the website and have cookies placed at the target in the target browser. And that's the idea of this concept known as a remarketing tag. So the tag that I have placed in the CloudGenius website is this remarketing tag that you see here. And that tag has been placed in 2,800 different computers worldwide. And those are the people that are seeing CloudGenius ads, or rather I should say, those are the people that I wanted Google to show them the ads, but then I have run out of budget. And that's the core idea behind ad network like we are looking at, which is we are using either Expedia or CloudGenius or Trivago. These guys, they are spending money, they're giving the ad, they're defining a target to a central agency, which is Google, and Google negotiates with a bunch of different publications, and these publications are showing the ads, and the rendering or showing of the ad happens through the ad servers here. And when users click on the ad, that happens through the click-through servers, which tracks the clicks of the users so that this business of ad serving can actually function. And that's the kind of pipeline of ad serving that you will see implemented very, very similarly by companies like Google, like Bing, Yahoo, Facebook, LinkedIn. Everybody will, in fact, let me show you the Facebook interface also. I was playing with that also. So advertisements.facebook.com. You will see that I'm not running something actively, but I will log in and show it to you how it looks like from a target perspective. You can actually very, very succinctly target a particular audience that you might have in mind. And so let me log in first. And so Facebook, and then where is the ad thing? Ads Manager. And here you can decide what kind of an ad you want to run. So right now I'm not running any ads, but you can create an ad and you can target an audience. You can say, you know what, I want to have brand awareness, generate traffic, and create conversions for people. So I'll create this campaign now. So this is just, I'm going to call it a test campaign, and then proceed forward. Then I'll select that I want people to visit the website. So that's the conversion, and view the content. And then I would like to have my audience that should look like something like my custom audience will be people who visit our website. That will be the site visitors. We know the number of people visit site have a cookie placed on their site based on Facebook pixel, which is this one. We have a Facebook pixel placed on CloudGenius website. So anytime who is visiting this site will also have a Facebook pixel apart from a Google pixel and a LinkedIn pixel based on all the cookies that you saw in a previous attempt. Every site you will have a structure like this will place a cookie, and that will inform the network such as Facebook or LinkedIn or Google to basically keep track of that person as a potential person who might be interested in what you're offering. And so that's how you create an audience profile, is one way to create a custom audience, because this custom audience is basically dynamically generated based on what people visit your site or your application or your services. That's one very nice way of constructing an audience that you have for your property, that your site or your service. That's the custom audience part. The second type of construction doesn't have to be like this, because when you start a new business, you don't have that flexibility or the ability to have site visitors already, because you don't even have a site to begin with. In that case, that doesn't apply. When you are new, this custom audience doesn't apply. When you're new, you have to actually go geographical and say that, you know what, this is not going to be available to me. So I remove that. Instead, I'll say everybody in the US, and maybe everybody in US and Canada. And you can expand your geographical location. So you can say include this location also, or add bulk locations. So you can specify that I want to have a country by the name Canada added. So match locations. and that's the country I want to add, and say add one match location. So now my ad will work in US and Canada both. I can then target my people in the age group of say 35 to say 65. Yeah, that's a good age. All men and women. If I like, choose the language I want to use. If I don't like French people, I can use English language and exclude Montreal if I like. So target a specific language. I can go even detailed targeting interest people in the Boeing company. You can go like that if you like, or people in Microsoft. You can target basically people specifically like that. I can say Microsoft and people from Microsoft who have a Facebook account. You can even go further and detail target people who are interested in Microsoft Office or Microsoft Excel, Microsoft Surface. So things like that, you can exclude or include people. You can also establish connections, people who like your page, people who have used your apps, people who have attended your events, and combination thereof. And that's how you can construct an audience profile. And then when you visit facebook.com, or rather when people visit facebook.com, that people will be able to see your ads like this one. For example, Volkswagen Jetta showed up, apparently because I seem to really like Volkswagen for some reason. At least Facebook thinks so. And so, or maybe I like this food that they're selling me, which is 2-hour delivery and Prime, which is actually I like. So that's what they seem to show me, because they want me to subscribe to Prime Now and get home delivery of 2 hours. And so that's how you see ads popping up, because of a pixel entry in my browser that knows that this person who logged in as Nilesh in this web browser seems to like Jetta for some reason, and Zoom video conference, which absolutely I love it. The Zoom we are using right now, and I don't know why they need to advertise. They don't need to advertise to me. I'm already a customer, but they don't understand this detail. They're advertising it to me, which is crazy. But yes, we are using Zoom, and yes, I love Zoom. And I just costed Zoom $10, by the way, by clicking on it. You know why? This top level property is very expensive for clicks. So roughly about $10 per click is what, if I click here, I might waste Volkswagen's $10. But just saying that this is how advertisements work in real life. And you can see that, occasionally you will see ads pop up, and you might not see too many ads in my profile, because I have indicated to not show me ads in the mainstream. So that's why you don't see ads, but occasionally you see them. Same exact thing in Twitter. You will see sometimes ads popping up in Twitter. Like, for example, this pop dust, whatever this thing is a advertisement. You can tell this is an ad by the fact that it is actually promoted. It's a promoted tweet, which is what they're doing. I don't know what this thing is, but whatever that thing is. So you can see that ads will pop up here in your feed, like pop dust again, apparently. And they think that I like avocado for some reason. And so they are promoting avocado to me, which is fine. And same thing again on LinkedIn. The same idea everywhere. Every network you go, there is a way to track behavior. And you see that this Earthlink seems to suggest that I want to download this white paper that Earthlink provides. I don't know why, but apparently that's what they think so. So they're suggesting me that I should use Earthlink white paper. I don't know why, but that's the idea behind advertisements. So I think that gives you good clarity on ad serving, ad click-throughs, and also the concept of the people who place the ads, people who publications who show the ads. So these people show the ads, these people place the ads, they spend money, they receive money, and these guys keep money. So dollar here, and double dollar goes out. That's the idea. So the money flows like this. So they give money, give ad, they show ad, give a portion of money, maybe not full dollar, but only a small little dollar. They keep the big dollar here. And that's what the ad serving business is all about from a cloud deployment perspective, from a from this illustrations perspective. Any questions on this before we switch again?
Nilesh, I have a couple.
Yes.
So does Google or Facebook give you any option to simulate and establish, any other business? For example, can you ask them, okay, can you show me who the publications are for DataCamp or something like that, which you think is probably, they're in the same business as you are in. Can you copy them or emulate them or something like that?
Yes, you can choose your publications, absolutely. So the question that you have essentially is, let me just quickly check. The question you have is,
so I want to use the same publications what DataCamp uses, because I feel they have an established line of business. So can I copy them? So
yes, you can select your target publications.
Okay.
Yes, most networks allow that.
Okay, and does the Google charge you a rate for each ad click, depending on what how big of a business you are, or do they see all that stuff, or is it the same for
they just treat everybody the same. You have to specify a cost per click.
Okay, that's it. Yeah.
It doesn't matter whether you're a small company or a big company. That's, you pay what you pay, and everybody will bid, and then the highest bidder will get to see the ad, get to place the ad.
Oh, okay.
Okay, so let's switch. Next one. I think we discussed this. So this is something interesting to Boeing, for example, I would say. So this illustration is very similar to what I suspect some of you in Boeing are accomplishing. I'll paste a link for you, and in the Slack chat, here is the link that I will talk next. It should be a not too long one, so I'm covering it today, and the next time, which is Saturday, I think I will go through an exercise. That exercise will be the link that I already gave you. And that's what I intend to do the next time. But for right now, let me grab this file, bring it down locally, save it, disaster recovery for local applications. And that's what I want to cover today. For the remainder, we don't have too much time for now. I think how much time we have? Yeah, it's like 15 minutes. So in this picture, which is about disaster recovery for local applications, the scenario is that if you have a situation where you have a local data center, corporate data center, like that, and you want to provide a method of recovering from disaster, and whatever you see in the bottom left corner is your local data center, corporate data center. And in that data center, you have your users, these corporate users, like this guy, for example. He or she is in the corporate data center, and they're accessing your applications and your database and your storage that you might have, which has storage volumes. And they are in the data center, and they are just running their business as usual. There is no cloud involved in the bottom left corner at all. This is local application servers. This is your local database server running Oracle production mode. And this is some disk network attached storage, or maybe some storage area network containing your disks available in a SAN environment. And what you're doing is attaching that storage network to a storage gateway. And that connection is how you will essentially take your storage volumes from here and map them over to a bucket in the cloud. So in the upper right corner of the upper right half of the picture, meaning whatever you see above this line, is the Amazon cloud implementation. And below the line is on-premises implementation. And that's the corporate data center that you have locally. So whatever you have here in blue color is on-premises. The orange color is the cloud. And that's the illustration. The point behind this picture illustration is that you will have a method of creating a scenario to prevent and recover from a disaster. Recover what? Whatever you are running locally. So you have an application server, a database server, some disks running locally, and you want to be able to recover from that disaster that might strike your local data center. If it does strike a disaster on your local center, your user, corporate user, should not be impacted. That's the idea. So how do you enable that? How do you pull it off? If for some reason this whole thing on the bottom left corner goes down, for some reason, disaster happens, you want your user to be able to recover from that disaster that happened in the lower left corner here, and the user should continue to run their business as usual, like they do, and they would not even notice that your data center is down because you are able to recover from it. This is the scenario that they're trying to illustrate. Now, in order for you to facilitate that thing and make sure that this corporate user transparently switches away from the corporate data center to a cloud deployment in a VPC in the Amazon cloud in this illustration, for that to transparently happen without this user becoming aware that, hey, that computer that they're using is not connecting anymore to this application server in the corporate center, but instead is connecting to the Amazon's virtual private cloud because of a variety of things. And that thing essentially is recovering from disaster. In order for you to recover everything that you have in the bottom left corner, you need to make sure that every single thing that you're running is replicated identically in the cloud. So that means you have an application server here. You need to have a similarly configured application server that's running in the production mode. You would like to have a similar application server running exactly like this in standby recovery mode in the cloud here. So this application server running in recovery mode is this unit, which is running in your Amazon's EC2 and is running the exact same application that you have here. And that's just one step, one piece of the puzzle. The second piece of the puzzle is the disk corresponding to this server that is running in the production mode. You have these disks and storage volumes that are stored locally. You want to use a systematic method of replicating these storage volumes over to the cloud. And so you essentially want these disks to be available to this application server locally, and a copy of these disks available to the remote application server here. Meaning you want to have these two elastic block storage volumes, this and this, these two guys, to be similar, identical actually, to these guys. So these storage volumes should map to these elastic block storage volumes here. And you can accomplish that through a product that Amazon provides called Storage Gateway. What it does is basically replicates this storage volume from here over to a bucket. And in there, you will keep snapshots of every single change that you will make in the storage here that will be propagated through the storage gateway and will be kept safe in a S3 bucket. Now, that storage volumes are backed up safely inside a bucket, you will also want to run Oracle backups. In this example, you're running Oracle database server. So you will like to have a similarly configured recovery mode backup database server running the same application Oracle server here and also here. And the data that is stored here in that database needs to be routinely, securely backed up to a bucket. And from that bucket, when a disaster strikes, that you want to restore the data, but not back here. You want to restore it to the Oracle server in the recovery mode. So you back up from here, recover it here. You have the disks kept here, these storage volumes. You want to recover from these snapshots that you keep for these guys and recover them and put them in the elastic block storage in these two volumes, these two volumes. And when a disaster strikes, that you can safely say that you have a successful backup, that you have kept and restored it in this location through the restoration from a bucket, this bucket, the backup, you restore here. These volumes that you have backed up through a storage gateway, you restore them here. And this application server that you have here is running in production, is already running here in recovery mode. So if a disaster happens in the bottom left corner, all you need to do is to make sure that the restoration begins immediately and get the latest backups loaded up in this location. These disks that you have are restored from the latest snapshots you have collected from the storage gateway backup from the actual machines that you had in the data center that died. And what you can do at that time, once the restoration finishes, to the disk as well as to the database, that you can change your DNS and have this corporate user not worry about this application server anymore, but instead have this corporate user point its DNS to the VPC gateway. And so that this user will transparently connect, instead of going to the bottom left corner, will go to the upper right corner to the VPC and continue their business like normal. And these recovery modes will take over, and the production modes are running through a disaster. And you recover from a disaster like that immediately without having to bother this corporate user. They're not even aware of the disaster. They just switched over because the DNS changed. And so the users migrated. Disaster recovered. And you were running locally. You went on to using the cloud. That's the transition that will happen if you orchestrate it like this in the context of Amazon's reference example. Similar to this, very, very similar to this is other clouds. You can basically replicate the backup that you have in a running database server, replicate it to some other database you have, some other server running the same database you have. So if you have, if say this is running PostgreSQL server in production, you run a PostgreSQL server here in recovery mode, you back up this database continuously, and when disaster strikes, you restore. You restore and you have it here, and you have it up and running. Same with here with the application servers. You have the same exact application server there. You have a disk storage locally. You want to replicate them, make it available here, and then you're back in business. That's it. I mean, there's nothing much to disaster recovery, is to basically replicate everything you have locally into the cloud on a item by item basis and make sure that you are able to switch on demand. If something goes wrong, you switch. It says that in case of disaster in the corporate data center, you can recreate the complete infrastructure from the backups on the Amazon VPC. And Amazon lets you provision a private isolated section where you can recreate your applications and all that. So basically what I described essentially is the idea behind disaster recovery. Where did that go? So what I want to be able to do next time, as I briefly mentioned, is I would like to do some exercises, because I think without exercises, understanding some of the complexity can be a challenge. And so I intend to run an exercise next time. I think I gave you a link already, but I'll just point it out to you again. And that is, it's coming up, loading up right now, is this exercise I want to be able to do. I think you can try that right away. If you like, I would suggest you play this exercise. It takes you 10 minutes to finish this. This is described here how to run it. But the problem that you will have is it will run just fine, but you will not understand what's going on. And I'd like to explain that is the exercise provided in this link, which is what I intend to cover the next time. Right now we are 7 o'clock and we intend to meet again at Saturday at 8 o'clock in the morning in Pacific time zone, 11 o'clock in the Eastern time zone on March 4th, which is a Saturday.
A question.
Yes.
When we have integrations like this, going from on-premise to cloud, is there? I mean, we definitely have to take into account the ingress and egress cost, the networking cost, right? So, is there any way to economize that? I mean, is there any way to save on that, or are there any options which the cloud providers give you to contain a cost, and what about the latency and all that stuff involved?
Yeah, so the cost saving can happen in a variety of ways. What you can do is if you can tolerate a little bit of downtime, if you can, what you can do is to skip creation of the VPC. Don't create it. Skip creating database server. Don't create it. Don't create this. So if you don't create an application server, don't allocate a block storage, don't allocate database server, don't have a VPC gateway, don't have anything else on this segment in this segment where I'm pointing my mouse. Just use S3 and snapshots. You can pull off a lot more cheaper solution. What you need to be able to do is make sure the backups happen and they get stored here in the bucket. Make sure that your storage volumes get backed up to the storage gateway and you are keeping them safe in the bucket here. And that's it. Now, when the disaster strikes, you don't have a ready-made solution to switch over. And therefore, you will take some time. And that will lead to downtime. If you can tolerate some downtime, it is cheaper because you don't have to run these guys all the time. And so now that you know that you have a disaster coming here in the corporate center, you know disaster has struck. So you tell this user, man, you go have some coffee, maybe go have lunch, come back after lunch, we'll fix it. And by the time the users come back after lunch, you will have ample time, maybe an hour or so, to start a database server, to have the application server started, depending on how big the infrastructure you have is. But you could provision an entire stack of application servers, database servers, and have them restore the entire snapshots in the disk here, as well as restore the database that you backed up from here, from the bucket onto the database servers, and have this entire solution constructed after the disaster strikes, and let this customer, corporate user, go to have lunch, or maybe take the day off if you can afford, and then have them come again. And then at that time, this entire virtual private cloud is up and running at that time, and the corporate user can continue and resume their business. Now, this action will involve some downtime because nothing was ready to go. You constructed a database server from scratch, constructed an application server from scratch, restored the whole thing. That takes time. If you can tolerate that downtime, it can become cheaper. If you cannot tolerate downtime, you have to have these things up and running all the time. And that adds to cost. You can cut the cost by not doing it and just taking some downtime. And when disaster strikes, you just declare holiday that day and say, you know what, our data center is down, go home, come tomorrow, we'll have it. And then by tomorrow, you have the whole VPC ready and you're done. If that is okay, that's a workable plan. If that is not okay, then it is not high availability. And then you have to plan for high availability, meaning all these things are not recovery devices, but active standby devices. They're running active in standby mode, ready to take over at a moment's notice of disaster. That's how you can optimize your cost.
True. And the only way to cut latency, Nilesh, is to actually choose a region closer to your data center, right? Or probably have any dedicated lines or something like which.
Closer to the user, not the data center. Choose the region closer to the user.
Okay.
The users may be in East Coast and your data center may be in the West Coast. If you have a disaster in the West Coast and your user in the East Coast, you would choose your region in the East Coast.
Got it. Okay.
Go to the user. Focus on the user. That's what I'm saying.
Right. This is great. Okay.
What else?
Nilesh, later on, are we going to talk anything about microservices, how they differ from the usual paradigm of SOA, how to go about constructing microservices, and
Yes.
probably a little bit about like how is data stored on the database, how is it encrypted how is data stored at rest during motion?
Hey, can you write these questions? I don't want to forget them. I want you to write
Sure.
these
I will make a list and send it to you.
in the chat right away. Like as you speak them, write them. So I don't want to forget them. I want to answer them, each and every one of them. So make sure you write them. Write them down in Slack chat as you talk.
Okay.
So I don't want to miss them.
Hey, Nilesh, the last, or the reason I typed in no is you were talking about whether we'd seen your ad or not, and I hadn't.
Aha, I see. You seen my what again?
Your ad for your...
Advertisement. I see. You did not. I'm actually surprised that none of you saw the advertisement, because there are 91 people who clicked on it. And if none of them is you, who's wasting my money?
Well, we wouldn't waste your money, but maybe we just don't read ads.
I know. Smart people don't read ads. And I think that's the reason why I'm tending to conclude that ad spending is actually a wasteful spending. And nobody seems to. And by the way, I showed you, like I spent $82.99 on 91 clicks in the last couple weeks, maybe less than 29,000 impressions, 91 clicks, and $82 wasted. What did I get out of it? Nothing. Why did I do it? I don't know, because I'm an idiot.
Well, maybe if you were watching like WorkSource or, target specific URLs.
No, I'm targeting the visitors, site visitors, remarketing.
Yeah.
I'm remarketing to people who visited, who have expressed interest in Cloud Genius. That's what I'm targeting.
Yeah.
So I think that's the most appropriate audience, because, if you show advertisement to random people, they have no idea what we do and they're not interested. So why bother? Right.
Well, it's dinner time. I'm going to take off. Thanks.
Yeah. And good to see you back, David.
Thank you. Yeah.
Bye.
Things went well.
Yeah.
Right.
Bye, guys.